So function, I mean, as you already know, it's basically a mapping from the domain to codomain, where every point in the domain goes to exactly one point in the codomain. Okay, uh, so uh, so what is the use of them? So of course, you can actually use them everywhere. I mean, another like one very important thing is that let's say if you have some big block of code which depends on some variable x or y. Okay, and and let's say it will be used repeatedly at several places later on in the code. Then you don't have to write the entire block of code again and again. Okay, you can actually hide that block of code behind a function. Okay, and let that function I mean, let that small, like, just write that once and then use that function later on, because it's there in the memory of the computer, so you can actually use that to uh, use that later on, I mean, whenever you need it, instead of writing the full code again. Okay, so let's just see how we can do that. Okay, so okay, so suppose you want to define a production function. Okay, so let me. Okay, okay. So suppose you want to define a production function that you might want to use later on as well to figure out how much is the output. Okay, so this is how we can do it. So consider the production function f1 lk equal to maybe, I don't know, L to the power. Let's take a Cobb Douglas production function. Okay, so let's consider this production function. Okay, so I'm going to define a function f1. Okay, so this is how we can do it in Python. Okay, so this was in, again, Markdown LaTeX. Okay, so this has no role in the coding. It's just for your, again, as I told you, it's just these are the notes which you can actually use to understand the code block that you have written later on. Okay, so define f1 lk. Okay, return. So basically, like, this is, when you use this def, okay, that means you are actually defining something, some function. Okay, and this is the name that you have given to the function f1. Okay, I mean, you can use other name if you wish. Okay, that's the name. It's like this variable name. Okay, this is the function name f1. Okay, and it takes two inputs, l and k. Okay, so now what does it return? Okay, so it returns this value. Okay, okay, let's print the output for some level of labor and capital. Okay, so let's say I want to print how much output will be produced if labor is 4 units, capital is 1 unit. Okay, So what do you think? What should be the answer? Sorry,
2.
that's right. Very good. Okay, so okay, and that's exactly what we have over here. Okay, is that fine? Okay. So now of course you can use this function anytime. You don't have to write this thing. You can simply whenever you want the output for some amount of labor and capital, you can just simply plug in whatever labor and capital quantity you are employing, and you'll get the output. Okay. Is this fine? Okay. Okay, so we can also define, other functions. Let's just define another production function. Okay. Okay. So suppose this is the production function. It is max of min of L comma 2k comma min of 2L comma k. Okay. So how do we write this function? Well, again, we can just do the same thing. Okay. F2 LK. Okay. Okay, let me first check if min is something inbuilt or not. If it is inbuilt, then I can just use that. Okay, otherwise I'll just write the code for it. Okay, so min of 2 comma 3. Let's print this. I think it is inbuilt function, so I guess we don't have to do much. Okay, so well, yes, so it is inbuilt. It's already inbuilt there, so you don't have to do it. So F2 LK. Return max of min of L comma 2 star k comma min of 2 star L comma k. Now let's print the output. Okay, so F2. So let's do that for 4.1 only. Okay, so 4.1. So what do you think will be the output? Yeah, it will be 2, right? Oh, I have already run it. Oh, okay. Yeah, it's already there. So it's going to be 2. Okay. Is it fine?
Yes, Professor.
Okay, okay, okay. Uh, so okay, okay. So let's see how to solve a utility maximization problem. Okay, I mean, now let's do some problem which we have, like, and which is actually kind of something that we see a lot in economics. I mean, solving an optimization problem. Okay. So I mean, in in machine learning also, it's all about solving one or the other type of optimization problem. Okay, so but right now we haven't gone over some of the interesting algorithms so that we can actually approach the problem faster. Uh, so what we'll do is we'll just employ some simple greedy algorithm, kind of to actually solve this problem. Okay, so let me tell you, that the what uh, what we can what we can do. Okay, so let's solve a utility maximization problem. Okay, I mean, even so, I'll give you some utility function. Okay, and I'll give you some budget constraint. Okay, and then we'll solve it. Okay, so we already know how to solve most of these problems theoretically. Okay, so we can also verify our results. Okay, because we know how to approach these problems by solving them theoretically. Okay, so consider the utility maximization problem. Okay. Sorry about that. Next time what I'll do is I'll just maybe type it beforehand. So that we don't have to waste a lot of time on this. Uh, but it's also good to learn some LaTeX. I mean it's very useful. Okay, so okay, so suppose we want to solve this problem. Okay, we want to maximize x times y subject to this constraint. So what is the theoretical solution to this problem? I mean, why don't you solve this quickly and tell me? So we know that the consumer will spend half his income on X and half of his income on Y. So if he's going to spend half his income on X, he'll buy 15 units of X, because 30 price of X is 2, so 30 by 2 is 15. And he's going to spend half of his income on Y, so he'll buy 10 units of Y, right? Okay, so that's the demand, right? Right. Okay. Great. So, let's solve this problem by writing a program. So because if you are able to write a program to solve a utility maximization problem, then even though this is kind of a simple problem, but let's say if you get some very different kind of functions, which may not be continuous, which may not be differentiable, or maybe some it doesn't have some nice properties. Even then you'll be able to actually solve that particular problem very easily by the same code that you have written over here. Okay, I mean, at least you'll get an approximate solution to the problem. Okay, which is actually a very good functionality. Okay, so so let's see, how we can approach this problem. Okay, so the way we are going to do it is, so let me just first show you, uh, how we're going to, like, what kind of code I have in mind, and then uh, I'll just tell you, like, uh, basically how to code it. I mean, so okay, so what I'm going to do is this. I'll just create a budget line like this. Okay, so what is the budget line over here? 60 by 2 is 30, so he can buy 30 units of X. Okay, and then 60 by 3 is 20, so he can buy 20 units of Y. Okay, and then this is the budget line. Okay, now all that you have to do is, uh, like, if you want to solve it, like, kind of, by kind of a search method, then this is what you can do is, you can start your search from, let's say, this point. Okay, I mean, you can start from here, wherever you want. Okay, let's start our search from this point. Okay, what I'm going to do is, I'll figure out what is my satisfaction level at this point. Okay, so what is utility at 020? Okay, fine. Now what I'm going to do is, I'll just store that value somewhere. Okay, I'll store that value somewhere. Okay, and I'll just say that, my guess or my solution guess is, X star is 0, Y star is 20. So this is, you can say this is my first guess. Okay, that X star is 0, Y star is 20. Okay, and I'll store that value of the highest satisfaction level, that I feel, is according to my first guess, in this variable U star. Okay, okay, and then what I'll do is, I'll move one step to the right. Okay, one step can be a small step, it doesn't have to be a big step. It can be like a small step, let's say, of length 0.01. Okay, something like that. Okay, so what will happen is, in the next step, X star will become something like this, 0.01, and Y star will be accordingly, whatever, according to the demand, according to the budget line, whatever Y you can afford, uh, sorry about that, that's not X star, Y star. Okay, so yeah, so in the next step, so basically, when you take the next step, then I'll compare this with 0.01 and whatever Y you can afford. Okay, so I'll compare the utility from this with the utility from, whatever, the corresponding X and Y you can afford. So if the utility from this is greater than utility from this, then I'll replace the X star by 0.01, and I'll replace Y star by the corresponding value Y over here. Is that fine? Okay, and if it is not, then I'll not do that replacement. Okay, so then I'll not do that replacement, and then I'll just move one step again, do the same exercise. At every time, I'll make the next step, I'll just do this comparison. Okay, and I'll replace the value of, my guess with the best so far. Okay, and you just keep updating this X star, Y star, and you just, when you actually end up searching the entire budget line, and you reach this point, then then of course, the X star Y star that you will have will be approximately the demand. Does this make sense?
Professor, in so essentially we're iterating through the values of x and y with steps of 0.01 in each, right?
Yeah,
For
so
the
zero.
feasible values.
Yeah.
Okay.
Sorry, yeah, just one. Yeah, can you repeat it? Yeah.
I was just saying the feasible values on the budget line.
Yeah. Yeah. So you'll be only searching on the budget line. Yes.
Right. Okay.
Yeah. Okay. So you'll be just moving, like taking tiny steps to your right. Keep updating the value of X star Y star. I mean, whenever you find something which is better than the existing X star Y star, you replace the value of X star Y star with whichever bundle beats it. Okay, and then you continue your search. And whenever you find something better, you just do the replacement, and then you just keep doing. I mean, that's basically the idea. Make sense? Yeah. Okay. So let's just try to write a code for it. Okay. I mean, I think that's going to be interesting. Okay. So you can actually, if you want to actually do this comparison uh, many times, so you can actually write a for loop, right? I mean, that's the best way to actually proceed, right? So okay, so let's first do this. Let me define some parameters. So px is 2, py is 3, okay, and income is 60. Okay, so these are the values of px, py, and m. Okay, and now what I'll do is I'll write a code which will work for every px, py, and m, so that I don't have to actually I mean rewrite this code again. I can just simply change px, py, and m, and you know uh, it will give me another demand. Okay, so okay, so let's start with guessing the solution. Okay, so my first guess is x star equals m by px, or let's start from here. Okay, so x star equals 0. Okay, y star equals, okay, y star equals m by py. Okay, so that's my first guess. Okay, and what is u star? U star is the utility at my first guess, which is u of, oh, I haven't defined the utility function. Let me quickly define that. Okay. Define u1 xy. Okay. Return x star y. Okay, so so u1, so u star is u1 x comma y. Okay, fine. Okay, so that's basically, I've just initiated some variables. These are the things which I'll keep updating. I mean, I'll just keep moving along the budget line one by one, and these are the values that I'll keep updating. Okay, is that fine? Okay, so now let me define the step size. I mean, uh, so so okay, so how to do that? Well, you can just maybe do something like this. Step. Okay, let me just think about it. Okay, let's do one thing. Let me define number of steps. Okay, so n steps. Okay, so what I'll do is uh, I'm going to take how many steps? Okay, uh, so basically, if you spend all your money on X, it's m by px, right? So I can actually define number of steps, depending on you know from 0 to m by px, basically how many one steps of size 1 are there. Okay, so if you see, the number of steps of size 1 are m by px, right? I mean, uh, do you agree? Yes, understood. Okay, so if I just take these many steps, m by px steps, so then what I'm doing is basically I'm starting with 0, 0 m by py, and then taking one step, and then moving on to 1 comma whatever, the remaining amount I'll be spending on y, and then 2 comma whatever remaining amount I'll spend on y, and so on and so forth. Okay, so there'll be exactly m by px steps. Okay, but if you want to break it into more tiny steps, you can actually divide it by some small number. Okay, so let's say epsilon equal to 0.01. Okay, and then what you can do is just take epsilon star. Okay, px, and then it will be like more number of steps, so these are the number of steps that I'll take to actually I mean um, along the budget line. Okay, so we have defined the required uh, variable names. Okay, so now let me write a loop. Okay, or maybe let me
Yes,
just give you, yeah.
Professor, U star should be U1 X star Y star, right? Or no?
Oh yeah, yeah. Yes. Thanks a lot. Yeah, yeah, that's right. Okay, that's right. Okay, thank you. Okay, is that fine? Okay, so okay, now let's write the loop. Okay, so these are the number of steps that you want to take. So I mean, so how will you write the comparison steps? Okay, so basically, if you really think about it, you'll start with some point, and then you'll take one step. Okay, and then another step, and so on and so forth. Okay, so uh, um yeah. Okay, uh, so if you really think about it, if epsilon is 0.01, your step size is epsilon. Okay, so if you want, you can use the word step size also, I mean, if that's better. Okay, you can just, I think that's going to be better. Okay, okay, fine. Okay, now let's start writing the loop. Okay, for I in range n steps. Okay, so this is what I'll be doing, at every step. So I'll be comparing. So okay, let me also do this. Just a minute. Okay. Let me also initiate x and y. Okay, I mean, this is what I'll be changing. Okay. Okay, so for I in range n steps, okay, so it will start with 0, and then what you'll do is you'll compare if u is if u is okay, just a minute, okay, yeah, so u star, okay, so if u is greater than u star, okay, let me just write it and then I'll explain it. Okay, so if u is greater than u star, then you define x star as x, y star as y. You can, by the way, you can also write it like this. Okay, I mean, in one step, you can. So x star will then take value x, and y star will then take value y. Okay. And u star, okay, will be the new u star will be u1. So this new x star y star, just going to plug in that. Okay. Uh, and okay, so this is my updating. Okay, so okay, so Anand, we can also like approach it that way. That's not a problem. But the what I want to write here is I don't want to write a code which will only work for one function. Okay, yeah, I mean this particular function. I mean, of course, we can solve it in many ways. We can even solve it theoretically. We don't even have to do this. Okay, but we want to write a code which will work for any function. Okay, so that is why I'm doing all this. Okay, I mean, just doing a simple search. Okay, just give me a moment. I'll just finish it and then we can discuss it. Okay, okay. So if u is greater than u star, then you just do this replacement. Okay, otherwise you'll just continue. Okay, I mean, you don't do this replacement. Okay, so but one thing that you have to do is you just have to update this. Okay, x is x plus step size. Okay, and this is something that you have to always do. Okay, x is equal to x plus step size, and y is equal to, so if you spend this much on if you spend px star x on x, then how much money is left to buy y? M minus px star x, right? Okay, and how many units of y can you buy in that case? Well, you can buy this divided by py. Is that okay? Fine. Is that okay? Now you have to also do this. Okay, you have to figure out what is u. Okay, so u is uxy. Okay, because that's what you'll be comparing. Is that fine?
Yes, Professor.
Okay, I think this should work. Okay, let's just see. I mean, if there is any error, of course we'll correct it. Okay. This is u1xy, right? I mean, this is the utility function. Let me use current utility for this. Okay. Well, okay, yeah. So let's run this. Okay, let's print out x star y star. Let's run this. There's some error. Ah, it's not range of n steps. Okay, it has to be so okay, so okay, you have to be a little careful here. Okay, so this is, first of all, this is not an integer. Okay, I mean, it may not be an integer because you have divided by step size, and then this is px, so it may not be an integer. Okay, so you have to convert it into an integer. Okay, is that fine? Okay, so so how do you do that? Well, you can just do something like this: int, you know, and then it will become an integer. Okay, fine. Okay, let's run this now. Not bad, right? Is that okay?
Yes, Professor.
Is that okay? So yeah, I mean, this is like a simple, search procedure which you can employ to actually figure out what is the optimal satisfaction level. Now, obviously, I mean, if I want to solve this problem, one way is I can solve another problem. One way is I can just change the prices over here, okay, uh, and then solve this problem. Just run this block of code again. But I don't want to keep doing that, right? I mean, let's say, for example, later in the code I need this again, so I don't want to keep doing that, right? I mean, so what we can do is, we can write a function, which will do exactly this. Okay, so we can then basically use that particular function later on also, to find the demand. Okay, so let me define the function. Okay, so this particular function will take as input, okay, the utility function. Okay, so it will take as input the function itself, okay, and the prices, okay, income, okay, and let's say the step size that you want. Okay, and let's say, you just choose the step size by default is 0.01, but you can actually change it if you wish. Okay, so now what we can do is this. Now all that we have to do is just copy paste this. So I don't need this. It's already defined. Okay, okay, return x star y star. Okay, let's just see if we can use this function to figure out the demand. Because if we can, then we can actually use this function later on also. Like, I mean, all that we need to do is define the utility function. Okay, whichever utility function we want, figure out basically whatever prices we are interested in, whatever income we are given, and then we can just simply use this function. Okay, and it will give you the demand. Okay, so let's just check that out. Okay, uh, So what I'm going to do is, I'll just use the same data, okay, that I have over here. Okay, so I've already assigned, px to 2, py to 3, m to 60. So if I print approximate demand at this function u1, okay, at this function u1, so this variable u will take value u1, okay, fine, and px will take value 2. So px is also, like, I mean, here also I've used px equal to 2, so I don't have to do anything, I can just simply write px, because the value that px takes is right now 2, okay, fine. So py, okay, again py is 3, so I can just simply write py over here, m, okay. Now step size, if you want to change it, you can just put whatever step size you want. Otherwise you can just ignore this, because by default step size is automatically 0.01. Okay, now all that you have to do is just run this. Okay, notice that you got exactly the same result, right? Okay, so now it's actually very very easy, right? I mean, later on, if you want to use you want to again find the demand in your code, then you don't have to rewrite the whole thing. Just use this function, whatever utility function you have in mind, and then just figure out the demand. Okay, now let's just solve some problem. I mean, let's think of some other utility function. Okay, and let's use this to find the demand. Okay, is this clear? I mean, is the code clear to everyone?
It's clear, Professor.
Oh, okay, okay. So let's look. I'm not saying this is the best way to solve utility maximization problem. I mean, there are more efficient ways to write a code, but that will require some more understanding of concavity, convexity, and so on and so forth. You can also use gradient descent method. I mean, that's another way in which you can actually solve this problem. That's actually a machine learning algorithm, to solve optimization problems. But I mean, this is kind of a very simple way of approaching the problem, and it is also quite powerful. I mean, in the sense that this kind of approach, you can actually also use in other kind of problems, and this is something which doesn't really require concavity, convexity. The only requirement here is that utility should be an increasing function, so that the consumer always spend all his money on goods X and Y. So Anand, that is why I said that this is an approximate demand. It is not going to give you the exact demand. You can reduce the step size if you are interested in, okay, and get more, like kind of uh, a more precise solution. Okay, I mean, but you cannot do it like a continuous thing. I mean, it's uh, in programming. Okay, okay, and it's not that bad, right? I mean, if the value lies between 0.0001 and 0.002, I mean, how does it make a lot of difference, right? I mean, it's just a very small fraction by which it misses the optimum. I mean, it's not going to make so much of a difference, right? I mean, to even the objective function. Okay, so you can just change the value of epsilon, whatever epsilon you're interested in, whatever step size you're interested in, you can change it over here. Okay, and it will give you a solution which is more closer to the actual solution. Now, if you see, the actual solution here is 1510, and this is not that bad, right? I mean, even if you choose this step size. Okay, okay, so let me define another function u2. Okay, u2xy is x plus 2 star y. Okay, so it's a perfect substitutes case. Okay, you also insert. Okay, so we have defined u2xy as x plus 2y. Okay, and now we can just solve the utility maximization problem for some px, py, and m. Okay, so let's say px is whatever value you want, or maybe we can just directly do this. Okay, so this is the use of this function. Okay, so what px do you want? Do you want to do it with the same px, py, m? Let's do it with different px, py, and m. So what do you think will be the solution in this case? Suppose Px is 2, Py is m, income is 10. What do you think will be the demand?
Be in the ratio 1:2, right?
No. So it's a perfect substitutes case. You'll just compare marginal utility of x divided by price of x with marginal utility of y divided by price of y. So if you see mux is 1, px is 2, and that's mux by px is 1 by 2. And marginal utility of y is and py is 5. So muy by py is 2 by 5. So between 1 by 2 and 2 by 5, which one is bigger? 1 by 2, right? So he's going to spend all his money on x. Okay, so that means the demand should be 5 comma 0. Okay, so let's see. Let's run this and let's see what are we going to get. Oh, well, not bad, right? I mean, just uh, you know close to 5 comma 0. Okay, if you want even like closer solution, you can just reduce the step size. Okay, yeah, step size. Okay, let's say 0.000001. Okay, let's run this. uh, okay, yeah, so this is actually uh, uh, fine, right? I mean, this is not bad, right? Okay, this is this whole term multiplied by 10 to the power minus 7. Okay, which is actually very small number. Okay, I mean, so you got the answer. Okay, so now you can write any function. Okay, any function that you are interested in. I mean, you have tested it on some functions that you know how to solve theoretically, so it worked. Now you can actually use it for solving any utility maximization problem. Okay, I mean, involving two variables, of course. Okay, is that fine? Shreyas, can you just make your comment public? I really don't understand. What do you want me to do?
Uh, okay, so I was using Jupyter Lab Professor. So in that, there's a presentation mode for viewing notebooks, and but it isn't in the normal notebook, so that's fine.
Okay, okay, okay. So is this clear? So can we proceed? Okay. So now let's do something interesting. Let's plot the demand curves, right? Okay. We can also plot the demand curves, right? Now that we know how to find the demands, so demand curve is a relationship between quantity demanded and price. Okay. Price of X. Okay. Holding price of Y and income as fixed. So what we can do is, maybe we can sketch some demand curve in Python. Okay, for that, we'll be needing like a kind of small tutorial on how to plot. Okay, so let me okay, so there is a library, Matplotlib, that you can import, that will actually give you this particular functionality, where you can actually plot the relationship between two variables. Okay, so let me well, of course it will give you on other functionalities as well, so I'll talk about that. Okay, so this is how you import some library. Okay, so use the import command. Okay, so what I'm going to do is I'm going to import matplotlib. Okay, dot pyplot. Okay, so this is a library that I will be importing. Okay, and I'll just instead of, so basically whenever you import something, then if you want to use some, so basically this library has lots of functions. Okay, or methods, you want to call it. Okay, methods. So if you actually if you import this library, so if you want to actually use any function from this library or any method from this library, then you have to use this, first, and then put a dot, and then whatever function that you are importing, like whatever function that you want to use from this library, you can put that after this. Okay, so since this is a long expression, I can just basically mask it by plt. So what that means is basically, like I'm just importing this, and whenever I'll use plt, it should be treated as this. Okay, that's what I'm trying to instruct to the computer. Okay, so so whenever I want to use any method from this library, I just have to put plt dot whatever method I'm interested in, and that's just going to give me the result. Okay, so let's see. Okay, so import matplotlib dot pyplot as plt. Okay, and then I'm just going to plot something. Okay, so let's plot something. Okay, so suppose x is 0 1 2. Okay, y is 0 1 4. Okay, and let's plot this. Okay, plt dot plot xy. Okay, so notice that these are lists. Okay, and now I'm just going to plot it. Okay, and then plt dot show. Okay, okay, let's run this. Okay, so here is the graph of xy relationship. You can see 0 0, and then this is 1 1. Okay, and then this is 2 4. Is this clear?
Clear, Professor.
Okay, now once you have this, now it is clear, right? I mean, if you want to figure out demand, demand and price relationship, if you want to plot it, then you can actually create a list of prices, and you can create a list of corresponding demands for X. Okay, and then all that you have to do is basically, just use the plot function. Okay, I mean, from PLT, okay, from matplotlib.pyplot. Okay, so let's do that. Okay, so let me just write. So this is what we are interested in: plotting the demand curve. Okay, for commodity X. Okay, when so let's hold Py and income fixed. Okay, so let's say Py is 5 and income is 10. Okay, and utility function is u2. Okay, so u2 is this. Okay, x plus 2y. Okay, right? Okay, so let's plot the demand curve. Okay, so how do we do that? Well, first we have to figure out, first we have to create a list of different prices. Okay, I mean, so how do we do that? Well, we can actually, of course, we can ignore the zero price. Okay, we can start with price 0.1. Okay, let's just create an empty list first. Okay, okay, so let me take prices from I mean, I can see that if price is high enough, then the consumer will not buy X. I mean, it's a perfect substitute case. So I mean, we can just take prices from, let's say, 0.1 to 10. Is that fine? Okay, let's take prices from 0.1 to 10. Let's create that list of prices from 0.1 to 10. Okay, now I still haven't done numpy. It will be very fast if you actually use numpy to create this list. There are a lot of interesting functions, for that can do that, but we'll do that later on. But let's see, how can we create a list of prices from 0.1 to 10. Okay, so from 0.1 to 10, using the loop, so we can actually write a loop. So, or actually there is a better way, okay, so 0.1 to 10, if you see, there are 100 entries. Okay, for I in range 100. Okay, px dot append. Okay, so basically, you just keep adding a price to px. Okay, of course, So you can start with 0.01. Okay, just a minute. Okay, because I will first take value 0. Okay, so what you can do is 1 plus I star 0.01. Okay, so that when I takes value 1, you can 0, or basically you can just start with 1. Okay, I think that's just going to work. Okay. So range 1 to 100 will be like it will start from 1 rather than 0. Okay, so now it should work. Okay, let's just print that out. Okay. Okay, you can see that you have created the list of prices 0.01, 0.02, and so on and so forth till 0.99. If you also want 100, you can put 101 over here and you'll get that. Okay. Sorry. I think I wanted till 0 to 10, right? Sorry about that. So just make it 0.1. Okay. Yeah, now it is fine. Okay. Okay, so we have created the set of prices, so we also want demands, right? I mean, we also want demand for X, so we can also do that simultaneously. We don't have to write a loop again. Okay, so all that we have to do is take xd dot append, and what do you want to append here? I mean, you want to append the demand, and what is the demand? Okay, so it is, okay, so we are given that py is 5, m is 10. Okay, so if you want, you can use a smaller step size. I think that's just going to be better. Okay, well, sorry, bigger step size, because that's just going to make it faster. Okay, and px will be basically this. Okay, fine. Okay, and now you can also print xt. Okay, so these are the demands. Okay, now let's plot them. Okay, let's plot the demand against the price of x. Okay, fine. Okay, let me clear this print. Okay, don't need it. So in case you are getting confused that this is also px, this is also px, like, don't worry about it, because this is kind of internal to the function, and you have assigned this value here. So so in this particular function, this is kind of a local variable. I mean, it's not a global variable. So now this is something which is global. Okay, so this is a value that px takes. So if you still have difficulty taking this, so you can actually just change the name if you wish, but it's not going to make any difference. Okay, I mean, I'm just doing it because so that you have clarity on this. Okay, so prices are in this. Okay, and demands are basically according to this. Okay, so that's it. Okay, fine. Okay. Okay, so now let's plot the price and the demand relationship. So PLT, since we have already imported this, so we don't have to import it again. We can just simply use PLT dot plot. Okay, and show price on the vertical axis. Okay, and demand on the horizontal axis. That's the convention. So we'll just do that. We'll stick to that. So So price on the vertical, demand on the horizontal, XD prices. Okay, and let's run this. Okay, so let me first run this. Now let's run this. What is this? Why is this extra graph? That is strange. Okay, anyways, this blue one is actually, if you see, is your demand curve. I don't know why it's just orange one is coming, from where it is coming. I mean, we just plotted one relationship. We have demand and the prices. This is a list of demands. This is a list of prices. Okay, so why is there an extra graph? Okay, anyways, so just ignore this orange one. I'll just fix this later and get back to you. But if you look at this blue one, okay, this actually gives you the demand curve, because when price of X is so if you just look at price of X, so I mean, the theoretical solution, right? So if MUX by PX is greater than MUY by PY, he's going to demand only X. If MUX by PX is less than MUY by PY, he's going to demand only Y. So if he's going to demand only Y, that means MUY by PY, which is 2 by PY, okay, should be greater than 1 by px, right? So that means 2 should be greater than py by px. Okay, so or basically, you can also write it as uh, px by py should be less than half. Sorry, px by py should be greater than half. Okay, so if px by py is greater than half, then you will be demanding uh, you know uh, 0 units of x. Okay, so if you see, when px is higher than 2.5, okay, so when px is higher than 2.5, you demand 0 units of x. Okay, and when px by py is equal to 2.5, you are kind of indifferent. Okay, and then when px by py is less than 2.5, you demand only x. So m by px, it becomes m by px, and so m is 10, so 10 by px. So it's just going to be like this, a rectangular hyperbola after that. 10 by px. Demand is equal to 10 by px. Make sense?
Could you go over the second part of what you were saying, Professor? The
Yeah,
rectangular hyperbola pattern?
yeah. So basically, like when px is actually smaller than 2.5, okay, then you demand only x, right? And how much amount of x will you demand? 10 by px, right?
Right. Okay.
Okay, so demand is 10 by px. So basically, it's just going to be like a rectangular hyperbola like this. That's the graph of the demand function. Is that fine?
Yes, Professor, that's clear.
Okay, yeah. So you can so this is how you can actually plot the demand curve, demand price relationship as well. Okay, I mean, uh, that's the way to do it. Okay, so uh, so do you want to do another exercise on this, or should we continue? Oh, I think that's the reason. Okay, that's the reason why you're getting two of them. Okay, now I understood. Okay, so so if you see approximate demand actually returns you not just X but also Y, right? Yes, it returns you a tuple, right? I mean, it returns you X as well as Y. So so obviously if you try and put that here, XD, so XD will consist of not just X but also Y. That's the reason why you're getting something like this. Okay, so this is actually the demand for Y as a function of price of X, this orange one. Okay, now if you just want demand for X, okay, then you just take the first element. Okay, just take the first element and now you'll get it. Okay, let's run this. Now this is fine. Is this okay? I think that's the reason. Okay? Because when you find the approximate demand, it not just returns X but also a Y, so it returns a pair. Okay, and that is why you ended up getting two graphs. One was the demand for X, this blue one. The other orange one was for the demand for Y. Okay, which here is actually, we have plotted demand for Y as a function of price of X. Okay, it's a cross demand, for Y as a function of price of X. Is this clear? Okay, you should also, always label your graph. Okay, so right now, it is not very clear. I mean, so you should always put a title, put a label on the vertical axis, put a label on the horizontal axis, so that by looking at the graph you know what it is. Okay, so this is a way to do it. plt.xlab. Okay, so this will label the x-axis. Okay, so you can put whatever you want to put here. Okay, demand for X. Okay, plt.ylab. Okay, is price of X. Let's run this. Let's check. Ah, I think it's just yeah. Okay, is this fine? pld.x label is this. pld.y label is this. Okay. And just actually, this is in R. It is X labs. Sometimes this just gets a little, it's just mix up. So no problem. Yeah. So and then you can just use plt.title. Uh, demand for X. Well, that is already there in the lab, so this is, so you can actually write the situation. Okay, so if you wish, you can just put R over here. Okay, uh, okay, so this is how you can actually uh, you know um plot the graph. Is that fine? Okay, of course you should also look up documentation on plotting graphs. So uh, So you can see, like, I mean, there's so many different graphs that you can actually use for visualizing functions. Okay, I mean, uh, it's actually very powerful. Okay? And not just functions. You can actually visualize data, which we'll see. Later on when we'll deal with data. Okay, so you can actually just say plot xy. This is what we have just done. So you can actually just use this. So this is another library that we'll be talking about soon. Okay, NumPy. It's very powerful. Okay, has lots of very important functions. Okay, and can use this. Is that fine? Okay. So let's do one more exercise. In optimization. Uh, so this time, what we'll do is, I mean, we can actually use the same demand function. So what this time what we're going to do is we'll plot the relationship between income and demand. Okay, so so basically again you just have to do this. Okay, so I'll give you the situation, and I'll give you 5 minutes to write the code. Okay, so you just have to use the approximate demand function. That's all. Okay, so I'll give you the situation. You have to write the code and tell me, how the demand as a function of income will look. So there is a name for this relationship. You also call it Engel curve. Okay, so it's also known as Engel curve. So you have to plot the Engel curve. Okay, so u1 was xy, right? Yeah, so let's use u1 xy equal to xy. Okay. So in Angel curve, you take price of x and price of y is given. Okay. Suppose price of x is 2. Okay. Price of y is 4. Okay. Uh, and you just have to figure out for income levels between 0 and 10. Okay. Okay. So you can put income on the horizontal axis, demand on the vertical axis.
Professor, could we get the approximate demand function?
Yeah. I mean, you just use this. Okay. I mean, you just need to know this. Okay. That's it.
Okay.
Yeah, because all that you do is just change incomes, right? So so just this code is enough to actually I mean see how to write a code for this problem. Okay, so you don't need what is behind approximate demand function. Okay, so just write a code like this. You can use the approximate demand function which is already there. Oh, you may not have it, right? So let me give you the code for it. Let me post it on Piazza. Is that okay? So you can copy it from there. Okay.
Yes, Professor.
Yeah. Okay. You can just use this code. Okay, and then after this you can just draw the angel curve. Make sure you label your axis properly. Okay, and then you can submit your code on Piazza itself if you wish. Okay, and then I'll just take the code from there, run it over here, and see if you got it right. Okay. So once you have submitted your code on Piazza, just let me know. I'll just check that. Okay. If you are facing any difficulty, just let me know. Okay. So you may have to import this also. Okay. I mean, just post that also. Okay. Are you done?
Professor, I've made a post on
You can make a
Piazza.
post. Okay. Just
Maybe I've gotten the formatting wrong.
that's okay. That's okay. I'll correct it. Whichever. Okay. So this is the utility function. Fine. Okay, and income list, this is an empty list generated for the incomes. This is the empty list generated for the demand, and now we are going to just append. Okay, so fine, since income levels are between 0 and 10. Okay, we can actually do this. And if you want to include 0 this time, it's fine. You can also include 0. Otherwise, you can ignore it anyways. Doesn't matter. Okay, anyways, we are starting with very little income. That's also okay. And then you can append the demand. So you're going to use this utility function, so we'll use this name u1 over here. Okay, and then px is 2. Okay, that's fine. Py is 4. That's fine. And income is exactly this. That's also fine. Okay, step size, so if you want because it is by default I think 0.01. So if you If you even want to skip this, it's okay. If you want to include it, it's not going to make any difference, because by default it is 0.01, so you don't have to assign a value here. I mean, if it's the same value that it is taking, unless you want to change it. If you want to change it, then in that case you have to specify this over here. Okay, otherwise you can even ignore this. Okay, fine. Okay, and then we are interested in the demand for X, so we'll just take the first element, which we'll get by using these brackets and putting a 0 in between, because it's the first element of the demand, okay, that we are interested in. And then since I already have it imported, so I'm going to remove it. Okay, and now I just have to plot demand on the income demand relationship. So I'll put demand on the vertical axis. Okay, so I'll just make a little change over here, because I want demand on the vertical axis, so I'll put that in this place, and income list on the horizontal axis, and that's it. Perfect. Okay, it should work. Okay, let's run this.
I think we'll have to flip the labels, Professor.
Oh, that's right. That's right. That's right.
Slipped my mind that axis will
Yeah,
apologize.
that's right. Okay, is that fine? Okay, okay, great, excellent. Is that fine? Okay, this is the angel curve. Okay, let me also add title. Okay, plt dot title angel curve. Okay, I mean, if you also want to include this data, you can also do that. I mean, it's a good idea to include the data, because then exactly for which function, I mean, for what variable you are finding the angel curve, and then what is the function, what is the utility function that is generating this angel curve. I mean, that will just make sure that your graph is properly labeled, titled, and it's just going to explain everything that is, it has everything that is needed. I mean, uh, all the information that is needed. Okay, so is this clear? Okay,
Yes.
Now figure out the theoretical solution to this. What is the theoretical solution to the demand? Remember, what was it? So if you find the demand function for X, what are we going to get? Demand is a function of income and price, when the utility function is XY. We are just basically verifying that it is exactly the same thing. I mean, that we just found it using, that we have just found using, uh, using a Python code. If we actually do it theoretically, we'll get the same thing. So can you tell me what is the demand for X, when you solve this utility maximization problem as a function of income and price? So remember, you spend half of your money on X, right? I mean, that's what you do in Cobb Douglas, right? I mean, in this case, with X times Y, the coefficient, the exponent of X is 1, exponent of Y is 1. So you'll be spending half of your money on X, half of your money on Y. So demand for X is actually M by 2px, right? Yes or no? Yes.
Could you come again, Professor?
Yeah, so demand for X is M by 2px. So solution to the utility maximization problem that I've written over here, so if you just replace this by px, replace this by py, replace this by income M, the solution to this utility maximization problem is M by 2px, because then it will be in terms of these M and px, right? Yes or no?
Right.
Okay, so the solution will be M by 2px. Okay, now what is px in this problem? Px is 2, right? Yes.
Right.
So what is the demand if you plug in px over there? Px equal to 2 over there, m by 4. Do you agree?
Yes, Professor.
So demand as a function of income is m by 4. Check that this is exactly the same graph. X equal to m by 4. This is m, this is x. X equal to m by 4. You know, when it is 0, it is 0. When it is 10, it is 2.5. So it's a straight line graph. X equal to m by 4 is a line with slope 1 by 4. Yes or no?
Yes, Professor.
Okay. So, you know, I mean, we've just verified that this is, you know, exactly what you should get. Okay. Okay. Any other questions that you have in what we have done so far? Okay. Now let's do one thing. Let's change the price of X. Okay. Let's reduce the price of X, and let's see what will happen to the angel curve. You know, and let's plot both the graphs in the same, you know, like same picture. Okay. So 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 how do you do that? You know, I mean, so let me basically, let's consider, you know, so this one was a situation when Px is 2. Okay. Now I'm going to also consider a situation when Px is 1. Okay. So you know, so I can just do something like this, xd new. Okay. And create another list. Okay. And just write xd new over here. Okay. And then Px is 1. Okay. Okay. And what I'm going to do is this, instead of just plotting this, I'll also plot in the same graph, okay, the second graph, the second angel curve, you know, for a different price. So what do you think will happen? You know, where will this new graph go? You know, I mean, how is that going to look like? Okay, let's run this. Okay. Can you see this? Okay, this is a new one. The angel curve shifts, you know, because of change in price of X. Is that fine?
Yes, Professor.
Let me just check the documentation once. Okay, we can actually do this kind of labeling also. You know, I mean, you know, that's uh, basically that's just going to tell us, you know, that this angel curve is for, you know, okay, let's just do that. I think it's better if I just keep it px equal to 1, and this is px equal to 2. Okay, so let's run this. I think I just have to just check how to actually get that. Just Yeah, I think we have to use plt.legend. I guess that's just going to give you that. Just, hmm, that's not. Yeah, this is fine. Okay. So you can see, the now it's just tells you exactly, this is the Engel curve when px is 1, and this is the Engel curve when px is 2. That's it. Okay, that completes the graph. Okay, it has everything now. All the information that is needed. Okay, I mean, if you want, you can include this also in the title. That's it. Any questions? So I mean, it's a good idea to do some Google search and read the documentation. Uh, whenever you need, that's the best way to learn. Okay, I mean, keep coding and keep solving problems, and of course, take help from the documentation whenever you need it. Okay, okay. So I guess we can stop here for today. So if you have any questions, I can take that. Otherwise, I'll see you tomorrow. Okay then. So let's stop here. I'll see you tomorrow.